So which is bigger, 2 to the power of 100 or 3 to the power of 60? We could compute these two values directly to find the answer, but it would be exceedingly tedious to do that without a calculator. So how do we determine which of the two is bigger without having to do the direct calculation? The first expression, 2 to the 100, has the smaller base but bigger exponent, while 3 to the 60 has a larger base but smaller exponent. So we're trying to determine which one has a greater effect on making the overall expression larger in the case of these two expressions, the larger base of 3 or the larger exponent of 100. We will be using these two properties on the side here to solve this problem. The first thing to notice is that the exponents in the two expressions are 100 and 60, which both have a common factor of 20, and we'll make good use of this. We'll use property 1, which states that a to the power of n, all raised to the power of m, is equal to a to the power of n times m. Since both exponents are divisible by 20, we can rewrite 2 to the power of 100 as 2 to the power of 5, all raised to the power of 20, which equals 32 to the power of 20. And we can rewrite 3 to the 60 as 3 to the 3, all raised to the power of 20, and this simplifies to 27 to the power of 20. The fact that both exponents are divisible by 20 ensures that the exponents inside the brackets are integers. So the 2 to the 5 expression inside the brackets has an integer exponent, so we can easily evaluate this to equal 32. And similarly, the 3 to the 3 inside the brackets has an integer exponent of 3, so we can easily simplify this as 27. So now we have rewritten both expressions, and these two new expressions are still equivalent to the original ones. So we are now comparing 32 to the power of 20 and 27 to the power of 20. Since both exponents are the same, we can use the second property here that if a is greater than b, then a to the n is greater than b to the n for all a and b greater than 0 and n greater than 0. This basically means that as long as both bases are greater than 1, and we are dealing with positive exponents, then if we have two expressions with the same exponent, then the one with the larger base is the larger expression overall. In this case, both 32 to the power of 20 and 27 to the power of 20 have an exponent of 20, but 32 is greater than 27, so this means that 32 to the power of 20 is greater than 27 to the power of 20. And we know that 2 to the power of 100 is equal to 32 to the 20, and 3 to the 60 is equal to 27 to the 20. So this implies that 2 to the power of 100 is greater than 3 to the power of 60. So the final answer is that 2 to the power of 100 is the larger of the two expressions, and this shows that the larger base of 3 wasn't enough to make up for the smaller exponent of 60 compared to the 100 exponent in 2 to the 100. What about this one? What about comparing 2 to the power of 100 and 3 to the power of 67? If we look at the exponents, we can see that 100 in 2 to the power of 100 and 67 in 3 to the power of 67 don't have any common factors other than 1, so we can't reduce the exponents that we need to compute in both expressions using a common factor in the same way we did earlier using only integer exponents. However, we can make use of fractional exponents. We know that 3 to the power of 67 is greater than 3 to the power of 66 and 2/3, since both expressions have the same base, and the 67 exponent is greater than the 66 and 2/3 exponent. So this implies that if 3 to the power of 66 and 2/3 is greater than 2 to the power of 100, then 3 to the power of 67 is also greater than 2 to the power of 100. We can rewrite 2 to the power of 100 as 2 to the power of 3, all raised to the power of 33 and 1/3, because 3 times 33 and 1/3 is equal to the 100 exponent in 2 to the power of 100. We can rewrite 3 to the power of 66 and 2/3 as 3 squared to the power of 33 and 1/3, because 2 times 33 and 1/3 is equal to the 66 and 2/3 exponent in 3 to the power of 66 and 2/3. So now both expressions have a 33 and 1/3 as the exponent outside the brackets, so we're really comparing 2 to the power of 3 with 3 squared. So we can simplify 2 to the power of 3 to the 33 and 1/3 as 8 to the power of 33 and 1/3, and we can simplify 3 squared to the power of 33 and 1/3 as 9 to the power of 33 and 1/3. Since 9 is greater than 8, this implies that 9 to the power of 33 and 1/3 is greater than 8 to the power of 33 and 1/3. And since 9 to the power of 33 and 1/3 is equal to 3 to the power of 66 and 2/3, and 8 to the power of 33 and 1/3 is equal to 2 to the power of 100, this also implies that 3 to the power of 66 and 2/3 is greater than 2 to the power of 100. So we already know that 3 to the power of 67 is greater than 3 to the power of 66 and 2/3. So if we combine that with the fact that 3 to the power of 66 and 2/3 is greater than 2 to the power of 100, we can infer that 3 to the power of 67 is greater than 2 to the power of 100, because 3 to the power of 66 and 2/3 is already greater than 2 to the 100. So of course, 3 to the power of 67, which is greater than that, is also greater than 2 to the power of 100. So 3 to the power of 67 is the greater of the two expressions. So what about this one? Which is bigger, 3 to the power of 91 or 5 to the power of 59? Looking at the two exponents, we can see that 91 and 59 have no factors in common other than 1, but we can see that 91 is close to 90 and 59 is close to 60, and 60 and 90 have a common factor of 30, which would work out nicely for reducing the exponents we actually need to compute. So we can consider comparing 3 to the power of 90 and 5 to the power of 60 first. 3 to the power of 90 is equal to 3 to the power of 3, all raised to the power of 30, because 3 times 30 is equal to the 90 exponent, and this simplifies to 27 to the power of 30. 5 to the power of 60 is equal to 5 squared, all raised to the power of 30, since 2 times 30 is equal to the 60 exponent, and this simplifies to 25 to the power of 30. Since 27 is greater than 25, this implies that 27 to the power of 30 is also greater than 25 to the power of 30, since both expressions have the same 30 exponent. And since we already know that 27 to the power of 30 is equal to 3 to the 90, and 25 to the power of 30 is equal to 5 to the power of 60, this implies that 3 to the power of 90 is greater than 5 to the power of 60. So now we know that 3 to the 90 is greater than 5 to the 60, but we wanted to compare 3 to the 91 with 5 to the 59. So notice how 3 to the 91 is greater than 3 to the 90, and 5 to the 60 is greater than 5 to the 59. So this means that 3 to the 91 is greater than 3 to the 90, which itself is greater than 5 to the 60, since we found that 3 to the 90 is greater than 5 to the 60, and that in turn is greater than 5 to the 59. So we can infer that 3 to the power of 91 is greater than 5 to the power of 59. So we did a comparison of two other expressions, 3 to the power of 90 and 5 to the power of 60, which were easier to compare to help with our original comparison. So we can conclude that 3 to the power of 91 is greater than 5 to the power of 59.